Welcome to Math with Mrs. Bibb. Today we will be discussing functions and continuity. Please use the following resources to fill in the definitions for this page. Number one, there will be a link. Let me grab my pen. There'll be a link in Google Classroom that will take you to the definitions. Those definitions are in Quizlet. We're going to use that Quizlet link to study for our vocabulary assessment we will be having soon. Number two, if you would prefer not to use that link in Google Classroom, then you may go to Clever and find our textbook, and the definitions are on pages 3 through 7 for all of these listed here. Or at any time of the day other than during our class time, you're welcome to borrow a textbook and write those definitions down. Those are also on pages 3 through 7 in the actual hard copy of the textbook. But please use one of those three resources to write down the definitions of these words that are listed here. Now for part A, example 1, we're going to identify the domain, the range, and the codomain of each graph below. So one way that I describe the domain, and I do want you to write this somewhere in the corner, and I'll look for it when I actually grade your notes. The domain is how far left or right a graph goes. And it's your x values. So how far left or right a graph goes. I will use a red highlighter when I'm talking about domain. I'll go highlight the x-axis now. Domain, domain, domain is how far left or right. Then for range, please write this down as well. The range is how far up or down. And the range is the y values. Okay, and I'll highlight in blue for the range. So your y values for the range. Okay, let's go find the domain here. I'm going to use a black pen. Okay, the domain is the red. How far left or right does this graph go? Well, this graph is going forever down and to the left, and it's going forever down and to the right. So it's going forever to the left and to the right. So that is written all real numbers. Or it is also written as, that's just all real numbers, but in interval notation, that is parentheses or parenthesis, negative infinity, comma, positive infinity, close the parentheses. And if you look, this is the same graph every time. It's just there's some stipulations that have been changed, and I'll go change that in just one moment. I'll go tell you about those in just a moment. So the domain for all of those is all real numbers because they're the same graph. They go forever to the left and to the right. The range How far up and down does this graph go? Well, we just said a moment ago that the graph goes forever to the left and down, and forever to the right and down. So it goes forever down. How far up does it go? This is the highest point. This black dot I'm putting on the graph, that's the highest point that that graph goes. So our y values are less than or equal to 0. In set builder notation, I'm going to write that in set builder. This is what it looks like. You use a brace y such that y is less than or equal to 0. In interval notation, that would be from negative infinity to 0 with a bracket. So let me explain that just for a moment. So this graph, these graphs, all of them start, I'll go grab the blue pen, start at 0 and go forever down. Start at 0 and go forever down. Start at 0 and go forever down. If you look at that, if you turn your paper sideways, I can't really turn my recording sideways, but if you turn your paper sideways and look at that number line, turn it to where the negatives are on the left and the positives are on the right, then you would see, and actually I'm going to draw it here, please draw it on your paper as well. You would see 0 colored in and all the negatives, 0 colored in and all the negatives colored in forever to the left. So reading this number line from left to right, where does it start being shaded red? It starts at negative infinity. And where does it stop? It stops at 0. So that's why the interval notation is negative infinity to 0. Both of those are the interval notation. Now, let's look. I kind of did this all wrong, but that's okay. Let's go back and highlight. The domain, we highlighted red. The domain is here. And that's this. The domain is everything I have there. So if you want to grab a highlighter and do that, you're welcome to do that. If not, just have all this written underneath there. Then the range is what's in blue. And that's all of this. This is all the range. And now we've got to name the codomain, and I'll name that above it. I apologize for not following those directions. Now the codomain has to be given to you, and it says, since it doesn't say what the codomain is, if it's not stated, then in the definitions you should have written that if the codomain is not stated, then the codomain is all real numbers. So the codomain of that function is all real numbers since it's not stated otherwise. Now let's look at this next one where it says check. It says for what codomain is f of x an onto function? Well, to be an onto function, the codomain and the range have to be the same. Well, this codomain is not stated otherwise. It's not stated at all. Codomain. So it doesn't say anywhere what the codomain is, so it's all real numbers. Or in interval notation, negative infinity to positive infinity. But the range of this actual graph, the range is how far up and down the graph goes. So I'm going to grab my blue highlighter. The range, the highest it goes is here, and it goes down forever. So if I go back, the highest it goes is here, and it goes forever down. So what is this point where I called here? 1, 2, 3. So 3 is the highest it goes. My y value is less than or equal to 3. So for this to be an onto function, the codomain and the range have to be the same, which is y is less than or equal to 3. That's the explanation for that particular question. Moving on to the next one. Okay, it says determine whether each function is one-to-one, onto, both, or neither. And then it gives us some stipulation. It says f of x, that's the blue graph, f of x, just to help us learn, and we'll write this on our paper as well. This is an exponential function. That's the graph of an exponential. Letter B, that's the graph of a quadratic. Please write this on your paper. And letter C, that is a linear graph. Now we want to know if this is one-to-one, onto, both, or neither for the given codomain. So to be onto, I want to write that up here, onto, codomain and range have to be the same. One-to-one, it has to pass the horizontal line test. And then we know what both or neither means. So let's check this first. Does letter A pass the horizontal line test? Let me grab my pointer here. If you drew a horizontal line, would it pass through only one point on the blue part of the graph? Yes. So letter A is one-to-one. Letter B, is it one-to-one? No. At all these points, the only point where it would be yes would be at the top. My horizontal line would only pass through this point one time, but it would pass through 2 points here. So it's not one-to-one. Is a line, such as this line that has positive slope, is that a one-to-one function? Yes, it is. So one-to-one. Okay, now the range. We've got to talk about the range for all of these. So I've got to find my range. So let's find the range for every one of these. If the range and the codomain are the same, then it is onto. So let's go through. The range for this one. Range is how far up or down a graph goes. So it looks like this is going forever up, but it's not going forever down. It's approaching 0, it looks like. So y is greater than 0, or, let me write that in interval notation, sorry. Y such that y is greater than 0, that's set builder notation. And in interval notation, that would be parentheses from 0 to infinity. Now the reason why there's a parenthesis at 0 is because an exponential function approaches, one such as this, that is, approaches the x-axis, but it will not touch or cross it. Although I would agree with you, it looks like it's going to cross there, but it does not. So the range is from 0 to infinity. The codomain is all real numbers. Are those two things the same? No, so this function is only one-to-one. Okay, so letter B was not one-to-one. What is the range? How far up or down does this graph go? Well, this graph is going forever down. How far up does it go? 1, 2, 3, 4. So it starts at 4 and goes down forever. So the range is y such that y is less than or equal to 4. Or, in interval notation, that would be from negative infinity to 4 with a bracket. And is the codomain the same as the range? Yes. So this is an onto function. Okay. How far up or down is this graph going? Well, this graph is going forever up and to the right and forever down and to the left. So this thing, the range is all real numbers. Or in interval notation, that would be from negative infinity to positive infinity, which means this is an onto function, which means it is both. So if you'll please make sure you have all of that written on your paper so you can remember those definitions. Moving on to the next slide. Determine continuity from the graphs. Are the following functions discrete, continuous, or neither? Remember, a discrete function is a discontinuous function where the points on the graph are not connected. So if you could look at A, B, and C, which one of those would you say that the points on the graph are not connected? And hopefully you could see that that would be letter C. That one is discrete. Okay, continuous, I think, is self-explanatory. It's a graph that continues forever. It doesn't have any breaks in it. And so letter A is continuous. And then letter B is neither because of that break in the graph. Now we want to name the domain and the range. So for each of these, we're going to name the domain and the range. The domain, how far left or right does this graph go? So how far left or right does this graph go? Well, it goes forever to the left and down, and forever to the right and up. Forever because of the ends, forever to the left and down, forever to the right and up. So forever left and right. So that means this is all real numbers. Forever down and up. So that means this is all real numbers. So I'm going to write that in interval notation so I don't have to write it in both forms. So how do I write that in interval notation? Negative infinity to positive infinity. The range, the same. Negative infinity to positive infinity. Now, letter B, how far to the left and right is it going? Well, it's going forever left and down, forever right and up, except for this point right here. So, for my domain, how far left and right is it going? I'm going to draw you a number line for this one because I think it'll be easier to read it from a number line. What is that ordered pair? 1, 2, 2, 1, 2, 1. So X, Y. So on a number line, if I think about this like a number line, my X value is 2. Here's 0. Here's 2. So X is open. The 2 is open. And it goes forever to the right and to the left. So how do I read that on a number line? From left to right, that would be negative infinity to 2, and then 2 to infinity. And you write that with a union symbol. So my domain is from negative infinity to 2. 2 is excluded, so you put a parenthesis. Then union 2, still excluded, to positive infinity. That's how you write the domain when you have a hole in the graph. It looks like that. And then for my range, I'm going to do the same thing. I'm going to draw me a number line. Except this time, the range is the y. So at 1, I'm going to have an open circle. And then it goes forever to the right, or down, and forever to the up, to the up. Okay, now let's read that from left to right, from negative infinity to positive infinity. So that range is going to look the same or very similar. It's going to be from negative infinity to 1 with a parenthesis because it's an open circle, union 1 to infinity. So that would be my domain and my range for letter B. Now for letter D, I need to know these ordered pairs. So let's name the top left ordered pair. Start at the origin. From the origin, count over -1, -2, -3, up 1, 2, 3, 4. So -3, 4. -3, 4. Let's do the next one. -2, -2. The next one, -1, 1, 2, 3, -1, 3. The next one, 1, 1. The next one, 1, 2, 3, 1, 2. So 3, 2. And the next one, 4, -1, -2, -3. So 4, -3. So my domain is the set of x values. Let's highlight those x values. Those x values are -3, -2, -1, 1, 3, and 4. Those are the x values. -3, whoops, thought I switched. -3, -2, -1, 1, 3, and 4, the x values. The range are the y values. So let's see, let's name them, then we'll put them in order. 4, -2, 3, 1, 2, -3. So -3 is the smallest y value. -2 is the next one. 1 is the next one. 2, 3, 4. So that's the range. And that's all for that slide. For example 4, we want to determine continuity. We want to look at this table. Determine whether the function models the cost of coffee beans is discrete, continuous, or neither. So when you first read it, here it appears to be continuous. Up to 2 pounds, it's $8 a pound, period. But then it skips. At 2.5 pounds, it's $20. At 3 pounds, it's $22. At 5 pounds, it's $35. So that means that this is neither a discrete nor continuous graph. So we're going to put neither. You don't even have to put discrete or continuous, we'll just put neither. And then it says state the domain and the range. So let's talk about domain would be your x, or your weight, and range would be your price. So let's put that on a number line. Domain. So, of course, we need to limit that from 0. We need to start at 0 because that would be our starting point. From 0 to 2, and then 2.5, 3, and 5. So we really can't put that in interval notation. We can only say between 0 and 2, and then 2.5, 3, and 5. Those are our x values. That's the domain. And then for our range, it's going to be from 0 to 16. Now, why 16? It says up to 2 pounds, $8 per pound. So 2 pounds would be 8 times 2, which is 16. And then we have 20, 22, and 35. So it would be 0 is greater than or equal to, excuse me, less than or equal to y, which is less than or equal to 16. And then 20, 22, and 35. Moving on to the next example. For example 5, we will be finding the domain and the range for each of these graphs in set builder and interval notation. So in set builder first, and then in interval notation. Okay. Set builder is the one that has the braces, and that bright brace was bad. And interval notation is the one that has infinity, negative infinity, parentheses, and brackets. Okay, so remember, domain is how far left or right. Range is how far up or down. So let's grab a highlighter. How far left or right is this graph going? It's going forever to the left and up, and forever to the right and up. So that domain in set builder notation is x, such that x is an element of, that's what that crazy E looking symbol, the set of real numbers. It's kind of like a block R, sort of. X, such that x is an element of the set of real numbers, or in interval notation from negative infinity to positive infinity. My range, how far up and down does this graph go? Well, it goes forever up, but the furthest that it goes down is to here, which is -6. So my range is y, such that y is greater than or equal to, because it's going up forever, -6. And then in interval notation, that would be from -6 with a bracket, because it's a solid graph, to positive infinity. That's interval notation for that. Now let's look at this next graph. How far left or right is this graph going? It's going forever to the left and down, and forever to the right and down. So it's going forever left and right, which is x, such that x is an element of the set of real numbers, and negative infinity to positive infinity. And for my range, how far up and down, how far up or down is this graph going? What's going forever down, and the highest it's going up is to here. This is the highest, which is 1, 2, 3. So y, such that y is less than or equal to, because it's going down, less than or equal to +3, or from negative infinity to +3 with the bracket. So one thing about interval notation I want to point out really quickly, if you'll please write this down as well. Interval notation is from smallest to largest. Negative infinity is the smallest, infinity is the largest. So your smallest number is always going to be on the left and your largest number is always going to be on the right. So just remember that for interval notation. And letter C for number 5, how far left or right is this graph going? It's going forever left and down, forever right and up. So both left and right, up and down, it's going forever. So x such that x is an element of the set of real numbers, or negative infinity to positive infinity. And then for my range, it's going forever up or down, so y such that y is the element of the set of real numbers. Or same, negative infinity to positive infinity. And one more slide. Same for this, we're going to write the domain and range in set builder and interval notation. So, as you can see, these graphs separate. So there's going to be a union, or we're going to use the word or. Union will be in interval notation, and or will be in set builder notation. Okay. So, domain, it's going forever to the left. What is that ordered pair? -1, -1. And then this ordered pair is 0, 2. So for my range, domain, x such that x is less than -1, less than -1, open circle, less than -1, or x is greater than or equal to 0, because my x's are -1 and 0. X is less than -1, open circle, so it's less than, greater than or equal to 0. Or x is greater than or equal to 0. In interval notation, that would be, let me color a number line really quickly so that you can see that. Please do draw that as well. -1, 0, open, closed, less than -1, greater than or equal to 0. So read from left to right. So it would be from negative infinity to -1 with a parenthesis, union, bracket, 0 to infinity. That's interval notation for the domain. Then for the range, I'm going to move my R down a little bit. For the range, it's going to be y such that y is less than -1. So -1 is that smallest y value, or y is greater than 2, because that's the y value on the second piece of that graph. Then I want to draw a number line again, like I did on the other one, so you can see what that looks like. -1 and 2. Oh, I think that would be greater than or equal to. Yeah, greater than or equal to 2. So open circle, shade to the left. That's less than -1. Close circle, shade to the right. Greater than or equal to 2. Okay, so let's write that in interval notation. So from negative, oops, did not need that brace. Parenthesis. From negative infinity to -1 with a parenthesis, union, 2 to infinity. I'm going to move this R down. It won't let me erase it. See, I'll just scribble it out. Okay, so here comes the last one, the last example for this set of notes. Okay, what is this ordered pair? -1, 1. 1, -1. how far left to right. So x such that this first piece is x is less than -1, or the second piece is x is greater than or equal to +1. Let's see what that looks like on a number line. -1, +1, open, shade to the left, closed, shade to the right, read from left to right, -infinity to +infinity. So my interval notation would be from -infinity to -1. I don't think I've said this up until now. -infinity and +infinity always get a parenthesis, and then union, bracket because of closed circle, 1 to infinity, with a parenthesis because -infinity and +infinity always get a parenthesis, and I tried to close that. Now let's look at the range. How far up and down? Well, it's going forever down and forever up, but there are limitations. So it is y such that y is less than 1 y is less than 1, or y is greater than or equal to -1. That's set builder. Let's draw the graph. -1, +1, closed on -1, open on +1. Now for the shading, at -1, it's going up forever, and at +1, it's going down forever, which then changes this. That's not necessarily wrong what I just crossed out, but all the numbers from -infinity to +infinity are our range. So if you will, cross that out, don't X it out, so that you can have that to look back at. Our range is actually y such that y is an element of the set of real numbers. So make sure you have that. Cross that first answer out and then put y such that y is an element of the set of real numbers. And I should have realized that when I was doing it. As we're going from -infinity up, there's going to be y values everywhere from those blue graphs. So that's why it's all real numbers. Okay, that's it. Hope you did okay understanding what we just talked about, and we will be practicing in class. Have a wonderful day.